Alright, so this is problem 11. Problem 11, we just want to evaluate this definite integral. This integral goes from 0 to pi over 4, and this is what we have to integrate. So pretty much we're just taking the antiderivative here again. In order to take the antiderivative of this, we got to go ahead and split this up into two fractions. We have this minus 1 divided by cosine squared, so we can separate this fraction into two separate fractions. So this is equal to the integral from 0 to pi over 4 of 2 cosine squared of x divided by cosine squared of x minus 1 divided by cosine squared of x dx. Okay, so by doing this, it helps us out a lot. Cosine squared divided by cosine squared, you can go ahead and cancel those out. So we're left with the integral from 0 to pi over 4 of 2 minus 1 divided by cosine squared is secant squared. So minus secant squared of x dx. Okay, so let's go ahead and find out what the integral of this is. So it's pretty much antiderivative. Find a function that when you take the derivative of that function, you get 2. Well, that function is 2x. So that's 2x. Minus. Now find a function when you take the derivative of that function, you get secant squared. Well, that function we know is tangent of x. And that's it. But now we have to evaluate this from 0 to pi over 4. So from 0 to pi over 4. So first plug in pi over 4 into the x and then subtract it by whatever the 0 is. So we'll have 2 times pi over 4. So that's pi over 4 minus tangent of pi over 4. So all this minus, now plug in the 0, so we have 2 times 0 minus tangent of 0. Okay, so what do we get here? Let's go ahead with this first. 2 times pi over 4, that's pi halves. Okay, tangent of pi over 4, we know that's 1. It's minus 1. 2 times 0 is 0, and tangent of 0 is 0, so we don't have to worry about that. So our answer then is this. We want to go ahead and simplify this, put it into one fraction. It's going to be this. So that is the solution here. So this might look very tricky. The only trick here, though, is to separate this into separate fractions. And when you do that, this gets reduced down to this. And this is a lot simpler than this. So once you have that, remember, you're just taking the antiderivative. That's what the integral is. You're finding the area under the curve, but if you want to think about it, you're also taking the antiderivative. So find a function that, when you take the derivative, you get 2. That function is 2x. And then find a function that when you take the derivative of that function, you get secant squared. That function is tangent of x. And then you evaluate it from 0 to 4. So plug in pi over 4 first, and then plug in 0, and that's what you get. Okay?